Welcome back again to another episode of F# Live Coding. We'll be continuing on our little app, the play tracker, or the how many hours did I spend playing video games tracker. We're gonna pick up right where I left off yesterday. So I added a new column with lessons learned because I typically maintain a journal. Like I have a software craft. I have a little moleskin book where I keep my notes. But I thought it would be cool for this project to track everything, or every new insight and every experience I have with the new tools in a lessons learned column. Maybe I blog about it, maybe I don't, but it's nice to have an overview of what we learned. Maybe first the obligatory recap of what we have been doing. We're building a small console app in F#6. Resharper is slow, we know that already. So we are building a small console app in F#6, but we don't actually use any of the new features. I'm using new IDE like Visual Studio 22. So far so good. And what the app actually does is you give it a CSV file with your backlog. Why am I dropping frames? So you give it a CSV file with your video game collection, and then for every game in your collection we look up how long the average player took finishing this game. We use this website called How Long to Beat to do those queries, and we do web scraping. And everything works right now, or rather we can parse the CSV and we can do the queries on How Long to Beat, but the thing that is missing is linking those two. So when I look up a game, for example, what was it? Zelda Breath of the Wild, I query the How Long to Beat website and we get responses with playtimes, but we don't get them just for Zelda Breath of the Wild, we get them for Zelda Breath of the Wild and DLC and the sequel. So we have to do a bit of matching still between what we query and what we get back. That's what I'm gonna focus on today. So let's take a look at the board. Something just popped in my head. The reason why I added this column, I haven't put it on there yet, but the reason I added this column is because I came to the realization that I'm doing something differently than what I coach my teams that I coach on the job. And I always suggest teams to slice their stories or their features vertically so that they have a working thing as soon as possible. So an end-to-end slice of their application and their architecture as soon as possible. And I don't even have that. I have like bits and pieces of the things. So I'm gonna quickly add that insight. Vertical slicing, MVP. That's just a quick reminder for me, but what I mean is, if I were to write this project again, or if I were to start this project again, maybe I should not only think about which tools and technology I should use, but also think about what's the smallest slice of functionality we can deliver end to end, and try to build that first instead of focus on the API of this first or the API of that first. So in this case, the minimal story I see is just give a game title, not even parse the CSV of my collection or have a collection of one game, sure. And just look up the playtime for that one game. That might have been a smaller vertical slice instead of like horizontal or puzzle pieces picking out the interesting parts. So yeah, that's why I added this column, and I'm gonna put it on top because that's the most important thing I was reminded of while building this little app. So let's dive into the code. What we'll be doing today, or right now, is the matching. So yeah, I explained that 5 minutes ago. I'm not gonna repeat myself. Matching search results with games. So let's give that a shot. I am currently running the app when I run it in debug mode or whatever. I'm running it against my full collection, and that full collection contains 300 plus video games. And we do web scraping of the How Long to Beat website. So every time I start my program, we look up 300 games by browsing 300 times to that website. And that's maybe a bit much if I were to run my code every 5 seconds. So I'm gonna be using the REPL or F# interactive heavily. So we only have to do that download of all that data once, and then we keep it in memory while we explore the matching algorithm. So let's do that first. Let's drop into the REPL. I always create a sandbox file to do REPL-like stuff. And I think this is already exactly what we need. But to be 100% sure, I'm just gonna copy paste. Yeah, I'm gonna copy paste the code in the main method, drop it in the REPL, add a file path, yes. Let's rename it so it all lines up. So now we do exactly the same thing in the main method, but in a FSX file, so in a file we can run and send to F# interactive. Let's do that now. And the cool thing about this is we do this query once, and now this responses variable has, or when it's finished, this responses variable has all the data, and we can write some code, try it out on that data, write some more code, try it out on that data, and it's all in memory. I never have to do those HTTP calls again during this coding session, or at least not in this REPL. There's one thing that's happening that I don't understand is after the 300 HTTP calls, so now this is the last game in my collection, and something is happening, I don't know what, but something is happening that takes a while. Okay, there we go. So now we loaded all the HTTP responses for all the, I don't remember how many games, but 300-ish games. Let's maybe print it out real quick as a reminder of how big the data set is. So we have 325 games, and now we have the HTML responses. Yes, we have the HTML responses of all those 325 games. For example, this appears to be a search result for Final Fantasy 13. And yeah, that's just some raw HTML. Let's maybe also parse that. Are we parsing here? No, we're not even parsing in here. Interesting. But let's quickly parse those results in the REPL. Let parse is responses, and we want to do something for every response. So let's map. And what would we want to do? How long to beat dot parse search result. So now we are parsing the HTML, and we get a list of a list of search results. So for every query we do, we get a list of search results. So that's why it's a list of a list. And let's maybe sec, if you're not familiar with F#, sec is the IEnumerable of F#, so it's a lazily evaluated list. And if you want to really evaluate it, you can, for example, do a to lists just like you would in C# to actually evaluate the entire sequence. This is new. Oh no, this is not new. So apparently in our main method we were not even parsing the HTML we got back. Now we are trying to do that, and stuff still blows up during parsing. So we are not as far along as I thought. Even better, we are crashing in the same place where we were crashing yesterday during the parse of a playtime. This is already the second time we're hitting a bug in this piece of code. And all we see is this. It's not a null pointer exception, it's a format exception. But I hate exceptions that don't provide enough context. And this is one of those cases. You see, like, okay, we're trying to parse a string into a decimal and it's not working. But what is this input? I would like to see the input. So maybe that's a small change we can do to improve our code. When this blows up, at least we know why or what the input was. We could do this with a custom exception and provide this information, or we can do it in a different way, so not with exceptions and exception handling, but with the type system, and that's with the result type. I think it's even on my backlog. There we go. So rework parsing from a exception-based strategy to a result, and result is a way to do error handling through your type system, so not through exceptions. That sounds pretty abstract, maybe. Now that I hear myself say this, it sounds pretty abstract. But I don't know if I want to do this right now instead of the matching, because my mind was set on matching, writing in the matching algorithm today. You know what? Let's not, and let's do the result first. I labeled it nice to have, but we have 2 encounters of a bug in this code, or a case we didn't account for. So maybe it's time to get rid of the nice to have label and make it just do this. Can I remove a label? Yes, okay. So let's first do that. Make errors more explicit, or provide enough context so that when something crashes, like in this case, we see what actually is going wrong in the stack trace or in the logs, not only by using a debugger. This will have some impact on our application, because again, we're going to touch the types to our public API of this module. What will change? Probably the search result won't just be or the return type of our parse. Which one is it? This one. It returns a list of search results, but probably we want to have the knowledge that things can fail and parsing can fail. We want to have that encoded in a type system, so the return type will probably have to change a bit. Is that the way we want to go? What could go wrong? We could get malformed HTML, but I don't think this is the problem. No. And then when we parse this HTML, we could get things we don't expect, which is what's happening right now, because the playtime, the HTML containing the playtime, we expect it to contain something like this. So blah blah or hours or dash dash if we have no playtime, but apparently there can be another case that we are not accounting for. So maybe an option is not the best choice, because an option is saying either we have something or either we don't, which is up until now I thought was what was happening. Apparently there's another case we're not seeing here. I'm just gonna do some debug driven development first and see what exactly the problem case is. So let's write out what we try to parse instead of reworking our entire application to use that result type. And let's go back to the REPL and try to parse that again, but then use the new version of this logic. So yeah, everything is still in memory. That HTTP call is still in memory, or the HTML responses, so we can just run the parser again. No, we can't. Expecting but I don't understand this error. It's expecting a function that takes a search response and returns something that's given something that takes a search response and returns something more concrete. Yeah, I don't see why that would be a problem. So okay, let's run everything again. There goes my argument of not having to perform those HTTP calls every time. In the meantime, we can take a look at all the good memories we had playing video games. Dead Space. I kind of forgot about that franchise. There we go. Wait, what? Oh, there we go. That is interesting. Apparently we have games that have playtimes in the minutes, not in the hours? Which game would have only 15 minutes of playtime? A short hike, maybe? But again, or not again, this indicates something. This indicates that now we know what the problem case is, but I don't know which game is causing the problem. So maybe let's log out the game that's causing the problem as well. Yes, we are sprinkling print statements around our code base. I don't care. I like doing it when I'm debugging F# code. I don't use the debugger all that often for F#. So let's log the title as well. And let's give it another shot. Do we have to? Do we have to do the HTTP again, or will it? Yeah, every time I load a new version of that file, is it because the HTTP call and the parsing is in the same file? Probably. So maybe I should copy paste the parsing code into this REPL as well, so we don't have to do all these API calls or HTTP calls every time I change some of my code. I'm still confused as to why oh, wait a second. I'm seeing a let here, but not a let bang. Is that why it looks like it's Let me try something quickly. I think I might have understood why it appears to be done, and then it takes a really long time to actually do something. I think if we wrap it an async computation expression around it like this. Yes, this, I think now when we run this again, now we will see the... I like the flowers, what? Excuse me? I like the flowers, what is this? Sorry, I'm getting sidetracked here. One of the things I noticed was when I run my code, it looks like it's done all the HTTP calls and then we have to wait for 30 seconds and I didn't understand what was happening. But I think what was happening is we were building like the async or the promise to do this HTTP call, and we were putting some debug statements before and after it, like you see here on lines 29 and 31. But I don't think they actually happened at that time, the HTTP calls. I think by doing this async computation expression and doing a let bang and a return, I think now we do sequence those statements. So if I call my shots right, we won't see this long hang at the end of the print statements of querying and finished querying. So let's see if I'm right. Yes, this is much more chunky and throttled. Okay, I'm glad we figured that out, because it was one of my lessons learned or have to investigate further. Did not use async and let bang, so the async promise was not running when I thought it was. There we go. So that's lesson learned. Okay, but we were troubleshooting a parsing issue in 15 minutes. And what is this? What is I like the flowers? What was the original query? And my current design does not really provide this information. Or we can see, like, we see Astral Chain passing, Grand Theft Auto 2 is passing, and then Xenoblade Chronicles is passing, and now we are looking at Flower. I think if we look up Flower on howlongtobeat.com, we'll see the problem in real time. So let's go to the website. And let's look up flower. Something with 15 minutes. There we go. Whoa. Now that I see this, I didn't expect my search or my queries to return more than 1 or 2 search results. But apparently running the flower search result gives us 1, 2, 3, 4, 5, 6. It gives us a lot of hits. So, or we don't take in every search result. We don't, in any case, because I don't do anything with this pagination and we do web scraping of the response. So I think we only have half the search results right now. I'm deciding between, should we parse everything we see here, or should we do some filtering before we do the parsing? That will be hard if we filter before we parse, because then we would be filtering raw HTML text. So yes, let's do the parsing first. Long story short, we need to be able to parse minutes as well as hours and no playtime logged. Okay, so let's grab this HTML to make sure we are looking at the correct string that we want to parse. I'm just gonna run query again in the browser. We could catch it when we run the query in the F# code, but let's do this. Minutes, we're looking for minutes. There we go. So this is a text string we should be able to parse when we parse playtimes. Let's drop into the tests. Over here we already parse hours and non-existent, so now let's write a new case for the minutes. And I would like to see that before the none case. 15 minutes. I currently use a decimal to represent playtime, and the decimal represents hours played. 15 minutes. That's a quarter of an hour, right? Yeah. So it should be some 0.25. That's funny. In C# you can do .25. Here it doesn't seem to like that. Now I'm thinking, is 15 minutes the only thing? Or are we gonna see 15, 30, 45? Or are we also gonna see something like 18 minutes? Because doing the conversion from 18 to a decimal number might be a bit of overkill. Or it's division by 60, so it's not overkill. It is division by 60, right? It's Sunday, it's early. I did not have a rough night, yeah. So maybe we just divide the number we see by 60 in our implementation. Okay, so I'm running the tests in the REPL now. That works because we loaded the REPL with the how long to beat module before. So we can run it a bit more quickly than compiling this code and running our unit tests. So it's failing for the reasons we expect. Let's quickly implement the logic to make this test pass. How will we make this test pass? Just look at the string, and if we see hours, we try to parse the hours. If we see minutes, we try to parse minutes. Yeah, let's just keep it simple. So if text equals this, we know it's none. Else, if text dot contains hours, we do the hours part, and otherwise we hopefully end up in the minutes. You know what? Because we crashed multiple times, I'm gonna do it explicitly. Else if then, you have to give it an explicit then keyword to F#. Let's just return some, or let's return none just now to make the compiler happy. So this should compile. Yeah, cool. And the else, or the thing here below, that's the I don't know if I like the if else, if else, but we're trying to make this green and then we'll refactor to something cleaner. So this is the error case. And again, I'm just gonna crash out. Unrecognized playtime format. And let's just print out the format. So next time it crashes, we at least see the text we're trying to parse. It'll be a runtime exception, so it'll bubble up all the way, but it's okay. As you see, I did not write a test first for this failure case because TDD is awesome, but it's not a holy grail. But we are trying to fix the minutes test, so let's try to do exactly the same as the hours case, but divide by 60. So split minutes, which was MINS with a big M. Yes. And there's a trailing space, but ours had the same format, trailing space. Replace halves with 0.5. Let's not do that just yet. I don't think we'll see half minutes in the responses. So parse it into a decimal and let's first divide it by 60. So we have a number or the string with a number. We just parse it. We don't even try parse it. And then we divide by 60. I think this might be what we need. Cool. So we save the file. Let's reload the module. That's in my REPL. Let's load how long to beat. Yes, it's loaded, so now we can run the test in the REPL again. Okay, that still works. The minutes case seems to work. Yay. Let's try 30 minutes. I don't even know if this is a response we'll ever get. Yeah, it seems to work. Yes, it seems to work. So let's run all our tests to make sure we have not broken anything. And if we're green, maybe we'll do a quick refactor. Because I don't mind if else, but if it's if else, if else, if else, if else, then maybe pattern matching or something might be clearer. Because right now it's really hard to read this function. It has no symmetry or no clear structure as to where should I be looking for the conditions, where should I be looking for what happens in that case. And I find pattern matching has a clearer symmetry. But let's first see the tests pass. As you see, they are very slow and I still haven't figured out what's causing the delay. The tests themselves are not really that slow, but the build and startup phase, that's very slow. We are in the green and it is taking our... Oh yeah, maybe my decision to keep every parsing test in a single test case. So it's like 1, 2, 3, 4, 5 assertions in a single test. Maybe that's not ideal, but I didn't mind when it was 2. Now it's 5 and there's like 1, 2, 3 big different cases. I just convinced myself. I'm gonna split these up. Parsing, playtime, in hours, in minutes, and missing playtime. So this is a test for the hours. This is a test for the minutes. And this is one for the missing. Why? To give me more granular feedback. If you have one test with 10 assertions, if the first assertion that fails stops test execution, if I split them up like this, we get a result for every one of these tests. So we can see if we broke the entire parsing algorithm or just the case for minutes or just the case for no data. It's a bit more fine-grained. Yes, that looks correct. Only thing I don't like is that I renamed the missing playtime and it has a different sentence structure. So I'm gonna undo that and keep keep it in the same structure. We could nest modules or nest stuff to make it more explicit that these tests belong together. But just for now, this works. So everything is green. Let's go into the refactor phase and clean up this if-else monstrosity. It's not a monstrosity, but let's try to make it cleaner with pattern matching. I'm gonna commit first because we fixed the bug actually. And maybe just to be sure, let's run it and see if we actually get further down the parsing sequence. It's really cool to see all the games fly by. Every line of text I see is like a memory of good times. This appears to have gone probably better. Yes, here we go, flower. So now we finished flower, but we are crashing on Legend of Zelda, A Link Between Worlds. That's another problem for another day. We can parse minutes, playtimes. So let's just check in. We can parse playtimes expressed in minutes. There we go. And before we dive into this next error, it's really tempting because it's in my face and it's a problem. Let's first stick to what we were doing and clean up this parser, or this parsing function, by refactoring it to a pattern match. So let's see if I'm just gonna put it next to each other so I can visually compare the two and see which one I like best. So I'm just gonna write a pattern match. So if we encounter this case, we do this. If we encounter the hours, so that means that the text contains this string, then we do the hours part. If we see minutes, we do the minutes part. And in the case of an unknown, we do the exact same thing, we fail. Let's comment out this if block just for a second, because I'm seeing green squiggly lines. Cool. Is this better? Don't know if better is the correct word here. If you don't use a variable in pattern matching, it's common to see like an underscore, but I kind of liked the opportunity for a name here. I could say like it's hours, and otherwise you have to scan this entire line, say hours when text contains hours before you know which case we're in. So I think I'm gonna leave this unused pattern match value in there for understanding. Do I like it better though? Only by a little. Maybe if we extract the actual parsing logic for every case into its function, so it's really clear what happens, that would even make more sense. But do I like it better than the if-else? Yes. I don't know. I can't put my finger on it. I can't explain why, but I like it. Right. Should we go further and extract many private functions for every case? It would make a different reading experience, because you would see when you look at this parse playtime function and you have a little 3-4 private helper functions in there, you would, when reading this or when scanning this function, you would see like, what are these little functions? And then you see the big pattern match, and then you, so now the order of reading, I think, makes more sense in this case. If they get any more complicated than the minutes, then maybe I'll split it up to have a clear distinction between pattern matching and dispatching to the correct parser and the actual parsing logic. But for now, I think we're gonna end the refactoring session here. Or at least if my test run doesn't bore me to death. There we go. Interesting. We have a failing test. So my refactoring that I took a really big step in because I reworked the entire evals into a match, I kinda did something wrong. Okay, let's take a look. Seems to be going wrong in the... Yeah, I see the problem already. What the hell? So if we have this case, it's the non-case. Why am I trying to parse hours? That's what you get. I have no resharper support for F sharp. So I do it manually and I take way too big steps apparently. Now I don't dislike this. I like it to be symmetrical, as I said. That's why I was refactoring to a match, better match. But my formatter does not like me putting it on a new line. It's another argument for extracting mini functions then. Yeah, when this test run is running, I'm just gonna see what it looks like if I extract helper functions. Oof. I hope type inference will allow me to not have to specify the type of these helper functions. Nah, apparently I have to specify the type. Because it has to be something that can be indexed. But why can't you look a couple of lines below? Typically don't annotate my types explicitly, at least not in private functions of a module. But now it looks like we have to... Okay then, let's do the same for minutes. Parse minutes. And let's just grab the implementation. I would be running my tests for every helper function I extract if they weren't slow as... Yeah, if they weren't as slow as they were right now. So I'm taking a bit bigger steps than I'm comfortable with right now, especially because we just wrongly implemented the non-case. But there we go. So we have these little helpers and we have the big dispatch, the pattern match. Now the hours and the minutes make a bit less sense. Let's keep it like this, run our tests. I'm happy with where we ended up right now. I'm thinking if I start fudging this layout, will my formatter agree with me or will he just convert it back again? He will convert it back again. Okay. I'm gonna leave it as is. If it works, it works. Cool. Am I happy with this refactoring session? Yes. Is there some duplication in there? Yes, but it's really small, so I don't mind. Cool. What actually did we do during this session? Is it only the refactoring? So refactor. I like to annotate my commits with what I'm doing. Am I adding a new feature? And am I adding new tests? Am I bug fixing? Or am I refactoring as we are now? So playtime parsing. There we go. Then I think we handled the 15 minutes correctly now. I'm gonna drag this back and make this a nice to have again. I dread the rework to result a bit because I don't dread it, but it's going to be a bit more involved than what we've been doing up until now. And maybe it's not a good idea to keep postponing it. But hey, we'll see where we get. Where are we now? We are at, I think, the next problem. So if I go back to the REPL, and I'm just going to rerun everything quickly to make sure we're working with the latest version of the code. And yes, this was the problem. We have, again, some HTML we don't expect. Some of our assumptions don't hold for every game. There we go. So we are parsing The Legend of Zelda, A Link Between Worlds. I don't think we're parsing that game actually. So we are crashing on parse search result HTML node, and we're doing something like sequence.head. Let's go take a look. Parse search result node. Yes, sequence.head. This. So we don't have a hyperlink in the HTML. Interesting. Yeah, only way to troubleshoot this is by looking at the HTML we get back. I'm thinking how we should proceed now. Should I put in a breakpoint and start debugging? Or should I start printing huge HTML to console? Maybe this is a case that warrants debugging. So I'm just gonna run it. Yes, I'm gonna run it and wait for the crash. Maybe it also makes sense, I'm just thinking ahead a bit, to split the HTTP call module from the... What? Something is crashing? Oh, I know what's going wrong. I see a problem already. I am working the REPL. And I did this bug fix with async, but I didn't pull this change of the code into my actual code. So I was running old code. I'm just gonna commit that as well. Async in main. And I should have looked at my IDE before I pressed commit, because we have a problem. It doesn't even compile right now because we have excluded the finished games filter. There we go. Let's maybe run it before we commit again. I don't push anything, and I have... This is a solo project, so it's not that big of a problem, but if I push this change to my team at work, I would have had to order donuts, or pastries at least. We call them koffiekoeken here in Belgium. What's happening? Is something happening? Is it just very slow? Okay. Sometimes if I click in a console window, the process just halts, pauses. Weird behavior. I see that our printing, we're doing like multi-threaded code right now, and our console is having some parallel problems. Apparently printing the console is not very thread safe. Man, the longer I see, or every time I see this list pass by, I'm dreading the answer. I think we'll end up in the thousands of hours that I played video games. Cool, we're breaking on the problem. No results for Pokemon Let's Go Pikachu? How can Pokemon Let's Go Pikachu not be a game? But anyway, we have another parsing issue. If we do a search or if we do a query for a game and we don't get any games back, currently we crash. Which is a bad idea. What should we do in the case of crashing? I think we should be returning a problem, because I don't expect to ever encounter that for real video games. What I mean is, I have a choice here: return an empty list, like there were no results, or return an error saying that you might have a bug in here, and I'm trying to decide which of the two is better. Maybe the empty list, like there were no search results, because that's literally what the API is returning to us. It's saying no results for this game. So maybe we should just return that info. Make it an empty list. So before we go any further, let me go to the call stack so we can write a test for this case. Yes, so the HTML here, this variable, this is the input for our tests, or we are writing unit tests on this level, on this parse search result function. So I would like to be able to copy HTML. Is that something I can do? No. In C#, when I double click on a line in the stack, I can see the local okay, there we go. I was just in the wrong stack frame. So yes, this is the HTML. It's minimalist, I like it. So this is the no games found for this query HTML. Let's grab that and put it in a test case. Let's make sure I grab that first. I don't want to denial of service attack the website again, just because my copy paste buffer is not working. Let's get rid of this. Language mode HTML should not have closed that previous window. And format. Oh. No results for Pokemon Let's Go Pikachu Eevee. Probably the database knows Pokemon Let's Go Pikachu, Pokemon Let's Go Eevee, but the CSV contains Pokemon Let's Go Pikachu Eevee, and that's a problem. That's already an interesting case if we think about how we will fix this. Enter the world of data science and mangling unclean data sources. But anyway, let's keep some focus first and let's handle the case of no games found. So drop back to our tests. Let's take a look at the HTML parsing. So we have two tests in this world: parsing actual results and parsing results that contain no playtime. And then we have a third case, parsing HTML responses with no data. So let's copy paste this bad boy. Excuse me? Why is the formatting all going crazy? Is there a way to drop back to the first tab? I don't know actually. But we are almost there, so let's not worry about it. There we go. I'm gonna get rid of this huge HTML blob. And I'm gonna paste in the no results found. I'm just gonna format it a bit, doesn't really matter. Okay, is this? Yes. With no games found. No results. For a game. So yeah. This should... Yeah, actually this is the test case, sorry. If we get HTML like this, we should return an empty list of search results because we did not find any. And those are actually problematic cases in our app because we never expect to hit a game that has no playtimes. So maybe instead of an empty list, we should be returning like, hello, there's an error here. Damn it. I'm ping-ponging between the two extremes. How will we implement this logic? I'm gonna keep it simple and just look for this string, I think. If this HTML returned contains no results for, we're out. So we parse the document, we parse descendants named list item. Yeah, that still works. We have a list item. No, let's keep the no results found separate. So we have the parse search result node, but this one we can put the no results in here. But already here we do a bit of parsing. So we dig into the HTML structure already. And maybe I want to keep the no results logic out of the actual parsing. I mean, out of the parsing of a search result. So I'm gonna actually use implement the change or the feature in this function, not in the actual parsing of a search result. Makes more sense to me. So I'm gonna extract some variables here. Let HTML document is this, and then just wait before I do that. Can I extract a variable? Is ReSharper or Visual Studio smart enough to do this for F#? No. I don't actually know. Does Ironite have better support for refactoring in F#? Because the Visual Studio and ReSharper combination is not really what I'm used to. When I write C# code, it's like I use shortcuts all the time to do refactorings. For F#, it's not all that supported. Or at least not in the toolchain I seem to be using. So we did the exact same thing. We extracted the variable, but now we have a place where we have the HTML document and where we can do something. And now that I'm saying this out loud, we don't actually need to go that far because we can just look into the string and see whether the string contains no results. So back out of it. There we go. So if HTML contains no results for, then we have nothing to report. Actually, we have an error to report maybe, but so this is how I would format it. But what does the Tom Thomas formatter think? They put then at the end of the line. Okay, didn't know that. Let's follow the tool. This probably fixes our test. Would I refactor something here? It's 2 levels of abstraction. Like we do some string matching here, and here we do actual HTML parsing, so maybe it warrants splitting up into little helper functions as well. But it's just 2 cases, and one of the 2 cases literally return empty list, so I don't mind all that much. Not proceeding with any refactorings. Okay, that works. I think we might have just shot ourselves in the foot with the empty list, because we're gonna forget all about it. And when we have to implement the matching algorithm with search queries and search results and look up which result is the actual search result we're interested in, maybe this makes it harder to detect that case. I'm not sure, but we'll see. Tests are green. I have not run our application end-to-end yet, so maybe let's do that as well. Let's do that just in the command line. Why not? I'm sorry, how long to beat? You must be seeing some popularity surges in your in your analytics. Hit me. We're almost hitting the 1 hour mark. Might take a quick break when we get this working. We're still printing out a whole lot, but the fact that it keeps going is a good sign, no? We actually parsed HTML for every game in my collection. I don't know how many of those no results found cases we hit. I'm seeing like all kinds of games I've never heard of, like Empire, Lord of the Seagate, Empyrean, Pokemon Empyrean, never heard of it. But one of the games I see here, Pyre, that one I have played, so that's the one in my shelf, my gaming shelf. Oh man, it's amazing to see how many video games and board games. If you look behind me, I also have quite a board game collection. Let's maybe pull it up. It's amazing to see how prolific video game and board game industry has become in the last years. There isn't a week where a big ass or a very good video or board game comes out. It's impossible to keep up with everything. That's my point, basically. But we are actually parsing results for every one of my games, so that's amazing. Parse no game found result from HLTB. And I think on that note, we'll take a quick coffee break. I'm gonna fill my coffee up again, and we'll continue with the matching algorithm, because I feel we're really close to finishing this side project. Take a look at the board. Wire everything together. Still not done. We still have to do the matching algorithm, so I'm gonna put that in next up. That's actually exactly the same as exact match, so let's get rid of this one. Orc. Let's get rid of this one. How do you do that? Archive? Sure. So yeah, next up matching, but I'm gonna take a 10-minute break. See you soon. Bye-bye.